Okay, so here's an example for a filter design. We're going to design this RL circuit to act as a low-pass filter. It's passive with a cutoff frequency of 100 Hertz. That means I only want to really measure low frequencies. This is rarely the case in traditional electronics. It's very often the case in biology. So a lot of biological signals are low frequency. And then on top of that, you only have 1 kilo ohm resistor. So obviously we kind of half solved it here. I know FC, which is 100, and I know R, so I just need to know L. So L will be R over 2 pi FC. So it's 10 to the third, 2 pi. I'm going to call this a 6. 6 times 100. So it's like 10 divided by 6, which is, I don't know, 1 point something. More than 1.5, less than 2, like 1.7. So I'm going to approximate this to 2 henries. So I would take a 2 Henry inductor or a 1 Henry with a half a Henry inductor in series and use that. So it's very approximate when you're trying one of these filters, because really the true Bode plot at this point here is already 3 dBs less, right? So here it's 0.7 of the voltage of the original gain. So really, it's very what we've been doing. It's back of the envelope. Now, if this had been an RC circuit, I'm going to change the example. Example 2, a low-pass filter RC with FC 100 and R 1K. I'm going to just now use this formula here, maybe with the blue pen, maybe with the black pen. I don't think I'm going to have enough space, so I'm going to put the C on this side, and then it's going to be 1 over 2 pi FCR, so 1 over 6 times, the FC is 100 times 1,000, that gives me 10 to the 5. So I'm going to put this capacitor in microfarads, so it's 1 over, it's 10 times 10 to the minus 6 on the top, and then 10 over 6 here. That 6 stays there. So 10 divided by 6 again is, I just did that here. It's 1.7 microfarads. So obviously I've got a 2 microfarad capacitor. So these are 2 examples. I realize it's not that interesting because the numbers are so similar. Of the cutoff frequencies for low-pass filters at 100 Hertz for an RL and for an RC. I hope this helps clarify how you can design a low-pass filter. There are several other circuits that also work as low-pass that have all 3 kinds of impedances, so R, L, C. And the method is always the same. You get the output voltage over the input voltage, and you notice that there are more poles than zeros. And then the graph, you sort of make the Bode plot following the poles and zeros, like we did in the previous video. 2 videos ago.